Order of operations with absolute values. Absolute values work just like parentheses, but they make the final number inside positive after it's been simplified. So let's go ahead and look at this first example. So right here we have this -3 raised to the third power minus 5 in absolute value, which is like brackets, these just up and down lines. So that indicates absolute value, which works just like our parentheses. So in order to solve for this, we're going to go ahead and rewrite our order of operations on the side. So we have parentheses, exponents, MD, and then AS. So please excuse my dear Aunt Sally. So absolute value actually works just like parentheses in also the steps in solving. So when solving, we need to first deal with that. So when we look at this, we see inside we need to also deal with the order of operations. So we don't have any parentheses, but we do have an exponent. So let's go ahead and rewrite that out. So we have negative. Now we have 3 times 3 times 3 minus 5. Then absolute sign and plus 10. So notice the exponent is not attached to the negative as it's not in parentheses. So we'll leave it outside. So now we can go ahead and go 3 times 3, which is 9, times 3 is 27. So when we rewrite this, it's -27 minus 5, absolute value sign, plus 10. So when we go 27, -27 minus 5, that is -32, because we can think of it as just going 27 plus 5, keeping the negative sign. So that's 32 plus 10. So now we've dealt with inside the absolute value sign and we've simplified it using the order of operations. So we did exponents. We didn't have to do multiply or divide, so we could just go ahead and subtract, do our final add and subtract step. So now we can go ahead and look at this. So when anything that's inside the absolute value sign, if it's negative, it just becomes positive. It makes whatever that is positive. So now we have positive 32 plus 10. So that is just equal to 42. And that would be our final solution to this problem. So let's go ahead and look at another example. Example 2, solve for the following. We have 4 minus 3. Then we have this absolute value sign of 7 minus 4 raised to the second power. So we're going to go ahead and rewrite these steps so we follow them. So we're going to deal with our parentheses first. So inside the absolute value sign. Now inside the absolute value sign, we see we need to deal with the exponent first, because we don't have any more parentheses inside. And so that would be our second step in our order of operations that we need to first deal with. So we have minus, and then we have 4 times 4, because that's what 4 raised to the second power is. We have 2 copies of the base number being multiplied together. So we can go ahead and rewrite this. Minus 3, absolute sign, 7 minus, so 4 times 4 is 16. Perfect. And then we can go ahead and solve, like simplify what's inside the absolute value sign. So we don't have to do any multiplication or division now. So we can just go to this final step. So we have 7 minus 16. Another way to look at it is we can go 16 minus 7. So 6 can go 6 minus 7 can't happen, so we have to borrow from the tens, and now we have 16 minus 7, which is equal to 9. But this is negative, as we have a more negative number than a positive number, so we know we need to keep the sign of the larger number. So we have 4 minus 3, absolute value sign of 9. So before we can go ahead and do multiple other steps, we can go 4 minus 3 Now this negative 9 becomes positive because it's in the absolute value sign. So we have positive 9. So now we need to go ahead and deal with the order of operations because we simplified inside the absolute value sign. So we don't have any exponents. So our next step is to multiply. So we're going to go ahead and multiply 3 times 9. This becomes 4 minus, and then 3 times 9 is 27. So we have 4 minus 27, which is equal to negative 23. Because we can just go 27 minus 4, which is 23, but we keep the sign of the larger number, which is negative. So we have negative 23 as our final solution. So let's do one last example. Example 3, solve for the following. So we have 2 absolute value signs in this one. Let's go ahead and rewrite it. So 1 raised to the 3rd power plus 3 minus negative 2 raised to the 2nd power minus 5. Close our absolute value sign. So when solving, we need to deal with our parentheses first. So we're going to look inside both absolute value signs, as absolute value is on the first step with the parentheses. So within the absolute value sign, we need to deal with order of operations, and we notice we need to deal with the exponent. So we have 1 times 1 times 1 plus 3 absolute value sign. Let's go ahead and also do it for the same for this one. So we have negative. Notice this 2 is only attached to the 2 because it's not inside. It's not attached to the negative sign because it's not in parentheses. So we have 2 times 2 minus 5 and then absolute value sign. So let's go ahead and multiply out. So we have 1 times 1 times 1. So that's 1 plus 3. Now we have negative sign. We need to leave out there. And 2 times 2 is 4. So we have negative 4 minus 5. So this really becomes, the first number becomes 4 minus, now we have this negative 4 minus 5. So we can just really go 4 plus 5, which is 9, but they're both negative, so it's negative 9. So we're going to leave that as is, like this. Now, remember, anything inside the absolute value sign will become positive. So we really have positive 4, which is already positive, minus positive 9. So this problem really has become 4 minus positive 9. Or another way to look at this is 4 minus 9. So when we deal with this, 4 minus 9, we can go 9 minus 4, which is 5, but we're going to keep the sign of the negative as it's the larger number, which is the 9, because this really is 4 minus 9. So this becomes negative 5 as our final solution to this problem.